All right, hey, all you cool cats and kitties. Welcome to April 1st, April Fool's Day. It's no joke, we're back into the math here. So, as you can see, the setting's a little bit different. I'm now recording all this stuff from home. So we'll see how this goes. First thing I want to do is check with you guys. Can you see the board okay? It looks like there's a glare right here. It's off of this one, okay? Still a little bit. So if I turn that light off, can you guys still see the board, or do you need the light on? Board looks pretty clear. Okay, good. So one thing, as you can tell, I'm working with a limited board space here, so I can see looks good. Okay, perfect, good. We have limited board space, so we'll have to change that up a little bit. Normally at the start of class, I give you guys all the stuff. So for today, it would be 2-7 and 3-7. That's going to be a little bit different now. So I'm just giving you 2-7 right now. We'll go through the 2-7 homework, the couple problems that you guys had posted on the discussion. We'll do those couple problems. Then I'll give you the information for 3-7, and then we'll do those problems as well. So for 2-7, we get into inverses of functions. So we have the horizontal line test. So if we have the graph of a function, if we draw a horizontal line, if it only hits the graph one time, then that function is what we call a one-to-one function, and therefore it does have an inverse. So one of the popular examples is if we have our square root graph. Looks something like that. Obviously, a horizontal line is only going to hit this one time, so that one would have an inverse. However, if we have a parabola with a horizontal line test, that of course is never, that's going to constantly hit something at least two times. So that is not one-to-one, but some of the homework you saw where it gave us the function of a parabola, but maybe told us that x is greater than 0. So if x is greater than 0, it's just the right half of the curve, and therefore it would be one-to-one, and we could find the inverse of that function then. So that's that idea. This guy here, this is important. This is going to be something that'll be tested on your ticket out the door today. It'll be tested on the exams. And this is the idea of domain and range for the inverse function and regular functions. So if I have, let's say that my function f of x has domain of all real numbers, so negative infinity to infinity, and has the range of, let's say, -1 to +1 in brackets. So we're just making this up. This is the domain and range of our base function. Make this a small f. Without even knowing what the function is, or without even knowing what the graph looks like, or any of that, I already know that if it has an inverse function, its inverse will have domain -1 to 1, and it'll have the range of negative infinity to positive infinity. They just swap. That's it. There's, this idea, the thing I keep telling you guys, essence of math is to make complicated things simple, not simple things complicated. So if you're given a question and it says, what's the domain of the inverse function? Well, if you know what the range of the base function was, you already know that answer. There's no work that even needs to be done. So any questions on that concept? If so, again, just type the 3 exclamation points. I know that tells me you're writing a question, and hold on for a second. And we'll see how this works today. I'm not opposed to doing like the WebEx where you guys can actually talk to me back and forth. I'm not going to lie. I would prefer that. Actually, I wish that was an option here with these, with the YouTube videos. So I may change that up. We'll see how this goes today and tomorrow with my 127 class. And if it seems like a better way is to do the WebEx version, then I may, no questions on that. So then how do we find an inverse function? What we're going to do is whatever the function is, we change f of x to a y so that we have y equals square root of 1 plus x, or whatever the function was. We move all the pieces around using our algebra, squaring sides, taking the square root, cubing, taking the cube root, etc., until we get x by itself, and then we just simply switch the x and the y. Now, I know some people have done these kind of problems before, and your teachers had you switch x and y at the very start and then solve everything for y. If that's how you learned it, and that method works for you, by all means, don't do it this way because this is how I listed it out. These two steps are interchangeable. If you switch everything right away, then you would solve for y. If you solve for x, then you'll switch all the x's and y's at the end. And then lastly, so when we were doing transformations of graphs, we had like things reflecting on the y-axis and things reflecting on the x-axis. The inverse functions, they reflect on y equals x. So that's our 45-degree line on the graph. So if I have, for example, the square root function, which would look like that, if I took and folded this board, or I think in the videos I mentioned, if you fold your paper in half, they should line up. If I folded this or reflected this across the 45-degree line, it would give me a curve that looks something like that. These guys are just the reflection across the 45-degree line, and that's how their graphs are related. So that could, as far as our concept questions, you remember those from the exam? We have a couple here. First of all, how is the domain of the inverse function related to the base function? It's the range. How is the range of the inverse function? This should be inverse. The range of f inverse is the domain of the base function. And then lastly, how are the graphs of f of x and f inverse of x related? They're the reflection across the y-axis, y equals x graph. So any questions on the concepts of 2.7 before we do a couple 2.7 problems that you guys gave me? Otherwise, I'm going to erase this. Obviously, if you need this further, you can go back and pause the video, rewatch it through YouTube and pause it, get the information you need. All right, so the first question you guys asked about, and again, I'm having you guys post these questions on Canvas so that I can see what they look like. So especially the screenshot of those questions, that way I know what your numbers are. So it looks like there was only one question asked from 2.7, and that was number 11. And it said f of x is equal to 1 minus x squared. And this is when x is greater than or equal to 0. And we have to find the inverse function. Well, why is it telling us this? Let's sketch this out real quick using our transformations of graph. Transformation of graph is what? So x is only bigger than 0. So x squared is normally our parabola, but instead it's just going to be the right half of the parabola. And then the negative in front does what? It reflects it on the x-axis. So instead of being this part, which is just x squared when x is greater than 0, reflects it on the x-axis. So now it's pointing down. And then this +1 in front does what? That's our vertical shift. So it slides the whole thing up 1. So we basically have that graph there. That's what this function is indicating. Now, if we want to find the inverse, what are our steps? Well, the first step is to change this f of x into the y value. Is equal to that. So any questions on any of this so far? And again, because you guys can't really talk to me, if you do have a question, type the exclamation point so I know to hold on and stop. All right, so then we do what? We want to get x by itself. So in order to do that, well, we'll leave it right there for now. So in order to do that, what do? I subtract 1 from both sides. So I get y minus 1 is equal to negative x squared. Then what? I have to divide everything by -1. So if I do these separately, so this divided by -1, that divided by -1. -1 divided by -1 is +1. Y divided by -1 is -y. And now the negatives cancel out over here. So I just get x squared. And then do what? Take the square root. Now, when we took square roots, we would normally do what? Plus or minus. But in this case, we're not doing plus or minus. We're just leaving it as x squared. But what we would have to do is indicate, as in the problem, it already gives it to you hard coded, what the values of x would be. So we take square root, we get square root of 1 minus y, and this is squared is gone. But this is not f inverse of x. F inverse of x has to have the x variable within the function. So the third step is to switch our x's and y's. That means y, which is really now f inverse of x, is equal to square root of 1 minus x. And then as the thing indicates, x has to be greater than or equal to 1. Greater than or equal to 1. So that would be your answer there, square root of 1 minus x. Any questions on that one? All right, so I know it wasn't asked, but I want to go through it because it's an exam question. So I don't know if you guys didn't get to it. I don't know if maybe you didn't have trouble, and that would be ideal because then you won't have trouble on the exam. But it's questions 7 and 8 from this section. And what number 7 is, the question is f of x is equal to x minus 2 over x plus 2. This one, so the last one we did was pretty straightforward. We just moved a couple pieces around, took a square root, and we were done. This one is a lot more difficult. And so I'm going to give you the steps of what you need to do to find the inverse of a rational function. So that's what this is called. This is a rational function, which we're going to see in 3.7, but it's basically a ratio, a fraction of two polynomials. So when we're doing this, first thing we're going to do, obviously, is set f of x equal to 0 to y. So none of that has changed. So this becomes y equals x minus 2 over x plus 2. Step 2. Maybe what I'll do is I'll give you the steps, and then we'll do it on the problem, and then I'll have you guys work number 8 to try that one. So second step, with this kind of problem, we're always going to multiply both sides by the denominator. I think Ginger's outside. Hey, Ginger. So this is her office. I stole her office. So she's probably going to want to keep coming in here. Maybe I'll show you guys to her later. All right, so multiply both sides by the denominator. Once we do that, we're going to distribute the y on the left side. Step 4, move all x pieces or x terms. So any term that has an x in it, move it to one side. And everything else to the other. So on one of the sides, we're going to have a bunch of pieces that have an x with other values to it. Maybe another variable, maybe a number, etc. So what we're going to do then is factor out an x. And then finally, to get so that's number 5, number 6, divide by, I'm going to put it the parenthesis piece. So we're going to have x times something because we factored out x. So we divide by whatever that something is. And that's basically our inverse function. We just have to remember to switch x and y. So any questions on that before we try to keep working this problem a little bit more? All right, so let's follow through here. So we changed it to y equals this. Step 2, multiply both sides by the denominator. So I'm going to multiply both sides by x plus 2. So on the right, the x plus 2's cancel out. All I'm left with is x minus 2. And on this side, step 3, distribute the y. So I have x times y plus 2 times y. Don't forget to distribute the y to all the pieces. Step 4, move all the x terms to one side, everything else to the other. So I'm going to subtract x from both sides. I want to get rid of the 2y from this side. So I end up with xy minus x equals negative 2y minus 2. So are we okay to there? I hope so. All right, step 5, factor out the x. And you'll notice when I was giving you guys these steps, I wasn't working with the problem that we had. Why? Because it doesn't matter. It doesn't matter what problem you get. These are always going to be the steps. And if you get to a step and you're like, wait, I can't factor out an x, then you have something wrong because these steps are always going to work in this order. So step 5, factor out the x, you get y minus 1. It's negative 2y minus 2. So these guys cancel out. So I have x equals this piece. But again, to get the inverse, I need to switch the x's and the y's. So I get y, which is really my f inverse. Whoops. F inverse of x is equal to this guy, but change the y's to an x. So negative 2x minus 2 over x minus 1. So any questions on that problem? Oh, I guess that creates a shadow. You stay over here, I guess. So you guys will need to know how to do this kind of problem for exam 3 for the final exam. You guys are okay? Any questions? Again, give me the exclamation points if you're trying to type something out so I know. Simplified? No. Nope. So that's it. That's as far as you're going to go there. So let me ask you guys this. If this, or like maybe the right word is when this problem is on an exam, is there any way to know whether you have this right or not, or you just have to hope that you did it right and see what the computer says when you hit submit for your answer? So is there any way to know if this answer is correct or not? Actually, with any problems, not just this one, but any inverse problem, is there a way to test it? Anybody have any options, any ideas? No, we're not going to plug in x for y. You can double check your work, but there's something that we can do with this. Solve for f of y. Not sure what you mean, Taylor, by solve for f of y. Maybe you might be trying to head down the right path there, but I'm not sure if that's what you mean. There we go. Yep, thanks, April. So if I plug the inverse into my original function and then simplify it, what should I end up with as an answer at the end? And this is with any inverse function. If I have to find an inverse, so I should have done it on that last one we did. If I find an inverse and I plug it back in, what? Yeah, I thought I thought so, Taylor. I thought that's what you kind of meant. That's what I was asking. Yes, exactly, as April says. So if I plug this into this function, so replace the x with this guy and replace the x in the denominator with this guy, simplify it, I should just end up with x. If I don't end up with x, then this is not the inverse. An example is what? F of x is x squared. And let's say f inverse is square root of x. Well, if I plug that in there, I get what? F of square root of x is equal to square root of x squared. Those cancel out, which is just x. So I know that these two are the inverses of each other. Good. Okay. So what time we got here? 1:22. All right. So let's do number 8. Again, I just want to make sure, so I know nobody asked about these, but these are important ones to be able to do these kind of inverse problems. So let me just have you try number 8. If you haven't done it yet, make sure that you're able to figure it out. You will have a ticket out the door like this as well. But we have f of x is 2x over x minus 9. So now I get a break from talking, finally. That's one thing I don't like about this, I'll tell you, it's just having to talk the whole time. But go ahead and try this. Find this inverse. Similar to class, if you have a question, type it here. I'll try to maybe help you as best I can. But yeah, so go ahead and try to find the inverse of this one. And I guess just so I know, once you guys are done, just maybe type in done. That way, as I see a bunch of people start saying that they're done, then I know. Okay, good. Okay. So you got there 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, about half of you still to go. If you're still working it, don't feel rushed. I mean, we have plenty of time, just like regular class time. So, take as much time as you need. We'll wait on you. That's fine. Okay. So maybe just a couple more. Looks like we only got about 17 or 18 people here, so hopefully that doesn't bad at the end of the semester here, or maybe you guys are going back and watching the videos later, but all right, so let's go ahead and work this one. So we do what? First we substitute in a y. Next step, multiply both sides by the denominator, the x minus 9. So it should always cancel out on the right side. All you should be left with is whatever was in the numerator. Distribute our y. So we have x minus 9y. Move all the x's to one side, everything else to the other. So in this case, if I subtract xy, I get negative 9y is equal to 2x minus xy. Factor out an x. So I'm left with 2 minus y is negative 9y. Divide everything by whatever's inside the parentheses. These cancel out. And now switch your x's and y's. So I get y, which is really f inverse of x, is equal to negative 9y over 2 minus y. So let me stop here for a second. Depending which way you move your x pieces. So if I would have brought the 2x over here and brought the 9y over, all of these signs are reversed. So this is an answer. Another possible answer would have been 9y over y minus 2. Maybe I should write or here. So there's always going to be two possible answers for this. And it just depends. Oh, yeah, the shadow. I better stay over here. It just depends on which way you move the x piece. So you could either have negative 9y over 2 minus y as an answer, or you could also have 9y over y minus 2. X. Sorry, yeah. Yep, thank you, Taylor. Yes, we wanted to switch the x's and y's. I got thrown off there. Yes, so it should be 9x, 2 minus x, or 9x, x minus 2. Thank you so much for pointing that out. Yes. The last step, switch our x's and y's. Again, the function is f inverse of x, so my functions can't have y's in them. They have to have x's. So yes, thank you so much for pointing that out. All right, any questions on that? Anything else from 2.7 before we move on to 3.7? All right, so 3.7 is our rational function. And we're going to be dealing with, so 3.7, we have some rational function. Let me see what notation I used here. So we have an x to the n plus a bunch of stuff until we get the constant at the end, a0. And then bm x to the m plus a bunch of stuff plus b of 0 at the end. So when we have this kind of problem, you're going to be asked potentially 7 different things. What's the x-intercept? What's the y-intercept? What's the vertical asymptote? What's the horizontal asymptote? What's the domain? what's the range, and then sketch it. So those are the 7 possibilities you could have for this type of problem. So let me go through this. First of all, X-intercept. So to find the X-intercept, and again, here's some concept questions. What do we need to do in a rational function to find the X-intercept? And the answer is quite simply set the numerator equal to 0. So technically we set the whole thing equal to 0, but as soon as we multiply by the denominator, it's gone, and all we're left with is the numerator. So the shortcut answer is just set the numerator equal to 0. That's how we find the X-intercept. The second one, is the Y-intercept. So when it says to us, here's a rational function, what's the Y-intercept? We set x equal to 0. So anywhere in the function we have an x, we make it 0. That's our Y-intercept. Third step, or third question, vertical asymptote. So it'll ask us, what's the vertical asymptote? And simply the thing for this is just set the denominator equal to 0. So we can get those 3 right away without a whole lot of work. Set the numerator equal to 0, set x equal to 0 for the Y-intercept, and set the denominator equal to 0 for the vertical asymptote. Now, the tricky one, or potentially tricky, is the horizontal asymptote. And what we're going to be doing for the horizontal asymptote is we are looking at the exponents on the very first term, what's called the leading term. And so we have 3 possibilities. If, let me see which order I did these in the video. So, all right, if n is less than m. So let's say in the numerator I have an x squared, and in the denominator I have an x to the third. So n is less than m, then the horizontal asymptote is just y equals 0. It's the x-axis. That's our horizontal asymptote. Second possibility, if n is equal to m. So if this is x to the third in the numerator and x to the third in the denominator, then my horizontal asymptote is y equals a to the n over b of m. So whatever the leading coefficients are, if this is a 8 and this is a 4, it's 8 over 4 or 2. So you just take that ratio. And lastly, if n is greater than m, then there is no horizontal asymptote. You actually, if it's difference by 1, you get what's called a slant asymptote. I will tell you now, do not worry about slant asymptotes. There's not going to be any in the assessments. There's none on the exam. There's none on the final. Don't worry about slant asymptotes. We're not going to deal with that. So any questions on that, how to find a horizontal asymptote, what we're looking for, how we figure it out based on our rational function? No? Okay. As far as domain and range, my suggestion to you is sketch the graph. Once you sketch it, you can see, okay, x goes from here to here, have to skip a point. Y goes from here to here, have to skip some point. That's how you would figure out the domain and range. I think that's about all I wanted to cover from 3.7. Yes. All right. So let's look at some of the problems you guys asked about. I'm going to leave that up for now. So the first one is number 4. And this one, it actually gave you a sketch. So it gave you that sketch, if I'm not mistaken, and it asked you for the four pieces of information, these main 4 here. So the first thing it asked for was, what's our x-intercept? Well, that's what? That's where this graph hits the x-axis, which is right here. And this point is what? It's at 4, 0. So your x-intercept is always going to be some number and 0. Your y-intercept is always going to be 0 and some number. So you have that ordered pair. Don't forget to put that 0 in there. So any questions how we get this, how we get 4, 0? It's going through this point here. The coordinates of this point is 4, 0. All right, y-intercept. This is where it's hitting the y-axis, which is up here. And this is what? 0, because I'm not moving left or right at all, and 4 units up. So 0, 4. Then we have our vertical asymptotes. So that's where is the dotted line, the vertical dotted line. Vertical asymptotes are always going to have the form x equals some number. And that number is wherever the dotted line is going through. So it's going through 2. So the vertical asymptote is just x equals 2. I think it already gave you the x equals. I think you just had to enter in the 2 there. And then the horizontal, this is always going to have the equation y equals some value. And it's wherever it's crossing the y-axis, and that's also at 2. So the horizontal is y equals 2. Any questions on that one? No? All right. So the next problem you guys want to see is number 8. And you have r of x is equal to 6x to the third minus 2 all over 2x to the third plus 5x squared plus 7x. Okay. So in this one, it wants the vertical and the horizontal asymptotes. So vertical asymptote, what do? We set the denominator equal to 0. So if I have 2x to the third plus 5x squared plus 7x equals 0, I have to do what? I have to factor this, maybe use zero property rule, etc. Well, what can I factor out of here to begin with? I can take out an x. And then I get what? 2x squared plus 5x plus 7. This whole thing equals 0. This guy here, and I'll be honest with you, I'm not sure why they give you this problem, because this is a complex number. We're going to get I, which is an imaginary unit. So this value, nothing, is ever going to equal 0, right? I can't put an x in here that would give me 0. So the only thing I have left is the piece in front. By zero property rule, x is 0, and 2x squared plus 5x plus 7 is 0. This doesn't give us any real solutions. So all we have for the vertical asymptote is x equals 0, basically the y-axis in that case. Any questions on that before I move on? All right, so then next, what's the horizontal asymptote? So for horizontal asymptote, we're looking for what? The exponents. I have x to the third. It's the same value. So my horizontal is what? Y equals, and just the numerator over the denominator, over 2, which is y is equal to 3. So my horizontal asymptote is vertical is x equals 0. Horizontal is y equals 3. Any questions with that guy? All right, so number 9. Two x cubed plus 3x squared all over x squared minus 4. And so this one wants vertical asymptote, put your smallest answer first. Vertical asymptote, the larger answer, and the horizontal asymptote. So go ahead and try those. Again, I'll kind of take a break from talking here. Let you guys work on those. And again, if you guys have a question, go ahead and try to type it out there. I'll help you as best I can. I think that's maybe where WebEx might be a little bit better. At least if you guys have a question, you can just ask me about it over the microphone. So we'll see. We'll see how this works this week, and I'll get your guys' opinion because I'm sure some of you are doing classes that have WebEx. And if you like that better, if it's a better learning environment for you, then by all means, I'd rather, do what's going to help you guys out better. So that's fine by me. And again, like before, once you guys have this, just type done. Then once I see the majority of you guys getting this, I know I can move on. So make the best use of your guys' time here. All right, looks like most of you guys are getting this. So let's go ahead on here. So vertical asymptote, 2, set the denominator equal to 0. So I have x squared minus 4 equals 0. 2 terms with a minus sign and an x squared. That should be screaming what? Hopefully this time it's screaming difference of squares. This factors into what? X plus 2. X minus 2 is all equal to 0. So x plus 2 is 0. So x is negative 2. And x minus 2 is 0. So x equals positive 2. So again, just like your test, WebAssign is telling you, put your smaller answer in first. So the smaller answer is what? Negative 2. Larger answer, positive 2. So any questions on that before we get into the horizontal? No? Okay. So horizontal, we're looking at what? We're looking at the exponents. I have x to the third in the top, x squared in the bottom. So the bigger numbers in the numerator, so n is greater than m. So that means what? Do I have a horizontal asymptote here? So the answer is no, right? There is no horizontal asymptote. It would be a slope asymptote. And so I think it tells you to put DNE. So yes, no horizontal asymptote. So the answer is just DNE. Does not exist. There is no horizontal asymptote. So does that make sense? Why there's no horizontal asymptote? Any questions about that before we move on? And again, if there is, there would be a slant asymptote, yes. But again, I'm not going to have you guys worry about slant asymptotes. It's not going to be on your exam. It's not going to be on the final. I'd rather you understand these 4 pieces of information as opposed to, worrying about slant asymptote. So yes, so we're looking at the exponents. So for horizontal, we're always looking at the exponents. So in this case, 3 and 2. And if they're the same, so like the last problem, it would just be like in this case, 1 over 1. If these were both 2, it would be 1 over 1. If the bigger exponent is in the denominator, so if the 3 was down here and the 2 is in the numerator, then our answer would just be y equals 0. It's always the x-axis. But in this case, when the bigger exponent is in the numerator, this indicates that there's no horizontal asymptote. It'd be a slant asymptote. So as far as this answer goes, does not exist. There is no horizontal asymptote. That makes sense? Hopefully. You good, Taylor? Or anybody else? Anybody else that had that question? You guys okay before I move on? All right. So next one, number 10. So I'll have you guys work this on your own here now. Okay, so number 10. R of x is equal to 4x minus 4 all over x plus 2. Now, before you start this one, or if you want to transfer it later, that's fine. What I am doing, since I obviously can't take attendance now, is one of the problems that we're working, I'll call it our attendance problem. So in your ticket out the door notebook, put this problem in here. So I'm going to give you 2 problems for ticket out the door at the end of today. That'll go in your ticket out the door notebook as usual. Put this problem as well. So when I'm counting attendance at the end of the semester, I'll go through and look for these problems. So for today, so for 4-1, this should be the problem that you have in there. If you want to write attendance next to it or something, so you know, why did I put this problem in there? At least you know. And again, if you want to do it right now in your attendance, in your ticket out the door notebook, so it's right there and you have it for practice later, that's fine. Reason being, this problem is very similar to what you're going to have on an exam. So if you can do this problem, you should be able to do any problem that you get on the exam. But again, if you can please put this in your ticket out the door notebook with the 2 ticket out the door problems that I'll be giving you at the end of today. Does that make sense to everybody, how we'll do that? So if for some reason, let's say one day you're not logged in, so maybe for our friends in Hawaii, maybe they're out at the beach once they get to go back to the beach, and they're like, I'll watch the videos tonight. If you rewatch the videos later, when we come to this problem, just make sure that you put that in the book. So, okay. Is this the first T? Yes. So this is the first ticket. This is the first one since the second exam. So So yeah, so this will be the start of the new batch of problems. Today will be the first set of ticket out the door problems since the last one that we had to do. And then this one, this attendance problem is new for the whole semester. So. But this will still go in your ticket out the door notebook. You don't need a separate notebook for these. Just put it on the same page as your 4-1 ticket out the doors. And again, once you get done with this, just type done so that I know you guys are done with these. You go to the beach. Yeah, I know. I heard that. I got a friend that lives in Hawaii, and he said that he's like, Hawaii is not as much fun when you can't go to the beach. So it kind of sucks, but hopefully pretty soon here. This is getting ridiculous. I mean, they have a cure. I don't understand why we're not ending this nonsense now. They know what'll cure it, like 98% cure rate, and yet they're still putting everybody on lockdown. So I heard the hotels here in Vegas, so anybody in Vegas, I heard the hotels are planning to open up and they're already like booking dates for, I think April 16th or something, I think is the end of the quarantine day. And I heard that they're already booking people for the hotels for the day as soon as quarantine is over. So that's pretty good. Hopefully enough people say enough is enough. So you can go, you just can't get a tan. Why, is it raining there or cloudy today? So I know these girls are in Hawaii. Anybody else that's not in Vegas anymore? You're dialing in from somewhere else. The lockout doesn't allow you to stay. Oh, I got you. So you can go and like touch the sand and then you got to go home. It's actually nice here today. It's supposed to be like 84, I think. So at least finally a decent day. Bad news. Apparently Sislak extending order. Ah, yeah, I did not see that. I'll be honest with you, I'm over it. Like I've been out and about. Like I said, they have a cure. Until they say they're going to start arresting people, then I'll probably be out doing what I got to do. So, wow, holy smokes. Okay, Billie Jean. What time is it there? Are you having to get up like in the middle of the night to watch these videos? So what are you guys? You're probably like 10 hours ahead or something, right? No, probably 10 hours behind. Oh man, okay. If you want, Billie Jean, if it works, I don't know how it works for your schedule, but I do the 2:30 class as well. Yeah. That's crazy. So yeah, if you would prefer, if you want to watch the 2:30 video instead, then it's at least a little bit later. You don't have to get up at 6 a.m. to watch this. That's perfectly fine. And not only that, but you won't be able to ask questions. But if for some reason you do oversleep or something, you can always go back and watch the videos. Yeah, that is brutal. So I know some people have a hard time making 8:30. So props to you for getting up at 6 o'clock to watch these. So. Anybody else? I know we got Hawaii, Guam. And then again, when you guys get done with this, just type done so I don't have to keep killing time here on you. But done. All right, so looks like you guys got this. So let's go through this. X-Intercept. So for the X-Intercept, we always do the same thing. Just take the numerator, 4x minus 4, set it equal to 0. So move the 4 over, so you get 4x is 4. Divide everything by 4, x is equal to 1. So the x-intercept would be when x is 1, y is 0. Ah, great, another one of these guys. So we actually got, I'm surprised that's the first one we've had. I figured out the other day that when I put these are educational videos, it prevents a lot of these knuckleheads from getting on there. So, all right, y-intercept. So for y-intercept, we set x equal to 0. So 4 times 0 minus 4, 0 plus 2. These guys just cancel out. So this is negative 4 over 2, which is negative 2. So the y-intercept is going to be when x is 0, y is equal to negative 2. Vertical asymptote. Set the denominator equal to 0. So x plus 2 is 0. Move the 2 over. X equals negative 2. Any questions so far? And last but not least, the horizontal. So I'm looking at the exponents. This is x to the first, x to the first. So it's just y equals 4 over 1, which is 4. So just y equals 4 is my horizontal asymptote. Any questions on that one? If not, we will do number 11. And I'll give you guys your ticket out the door. So again, please put this problem in your ticket out the door notebook. That'll count for your attendance. And number 11 is similar. Oh, okay. Yep. Question. I'll hold on. I hope I didn't erase anything. No, there's only one vertical asymptote. We just set the denominator equal to 0. So the previous problem there was because it was x squared minus 4. So we had 2 vertical asymptotes. With this last one, we just set the denominator equal to 0, then solve for x. So you get x equals negative 2. And that's it for your vertical asymptote. We need to sketch up the graph on ticket out the door. I don't believe I make you sketch it, no. All right, so number 11, last problem from this section. So you have r of x is equal to, was that your only question, Taylor, hopefully? So I'm gonna move on here. We have 2x plus 6 all over negative 6x plus 3. So go ahead and try this one. Same thing. What's the x-intercept? What's the y-intercept? What's horizontal asymptote? What's vertical asymptote? So go ahead and try this. We need to state domain and range. Yes. So for the ticket out the door, you will have to state the domain and range. So maybe on this one, even though I know it doesn't ask, I'll show you guys how to find domain and range. The easiest way, I'll be honest with you, is to sketch it. So if you sketch out the graph, that will basically tell you what your domain, or show you rather, what the domain and range is. So we'll do that on this problem. So go ahead and figure out just the first 4 pieces of information here: x-intercept, y-intercept, vertical asymptote, horizontal asymptote. Tell me done when you're done with that. And then I'll show you guys at the end how we can find domain and range by sketching it. Whenever we have a sketch, it's a lot easier to see that information rather than try to figure it out from looking at a rational function. Okay. All right, looks like you guys are finishing this up. Same process again. X-intercept, set the numerator 2x plus 6 equal to 0. We have 2x's negative 6. Divide everything by 2. X equals negative 3. So the x-intercept is negative 3, 0 as an ordered pair. Y-intercept. So y-intercept, we set all the x's equal to 0. So 2 times 0 plus 6 over negative 6 times 0 plus 3. These two cancel out. So you get 6 divided by 3, which is 2. So this tells us our y-intercept is 0, 2. Vertical asymptote. Set the denominator equal to 0. So negative 6x plus 3 is 0. Move the 3 over, so negative 6 is negative 3. Divide everything by negative 6. Tells me x is equal to positive 1/2. And last but not least, horizontal. So we're looking at the exponents. First power, so it's just the ratio of these guys. So y is equal to 2 over negative 6, which if I simplify is y equals negative 1/3. Does that make sense there? So our x-intercept, our y-intercept, vertical asymptote, horizontal asymptote. So now that I have that information, so I'm going to erase this now. I'll leave the answers, but I want to show you how we can sketch this now based on that information that we have. So our x-intercept is what? Negative 3, 0. So that's over here. That's where this graph crosses the x-axis. The y-intercept is at 0, 2. So up here. So that's the only place that it crosses the y-axis. Vertical asymptote is x equals 1/2. So that's roughly here. And the horizontal is at y equals negative 1/3. So somewhere down here below the x-axis. So does that make any sense? Or I guess, does that make sense? Or maybe I should say, is there any questions? And if so, you can type the exclamation point. All right, so now to sketch this thing. Well, I know the graph has to go through these 2 points. So I know that I have this part right here as part of the graph. So then the question is, where does the rest of the graph go? Well, can I have any part of the graph in the upper right here? And the answer is no. Why? Because if I had some graph that was up here, what would I have? I would have another X-intercept. I only have one, -3, 0. So I can't have any piece up in this section. What about down here in the lower left? Well, same reason. If I had some graph down here, I'd have another Y-intercept. I don't have another Y-intercept. I only have one. So there's no way that there's part of the graph down here. So the only other place that this graph can be is down here in the lower right, because then it doesn't hit the X and the Y axis again. So that's how you can figure out, rather than, like I know in the videos I talk about end behavior and things like that, you don't really need to do that, because you know if the graph is up here hitting these 2 points, it can't be in either of these areas because it'll hit the axis again. So the only other place is down there in the lower right. So now that I have the sketch, now I can figure out what my domain and range end up being. So the domain is what? The domain is all the X values. So what X values do I have here? Well, I have everything from -infinity up to what? Up to where this asymptote is. The asymptote's telling me no X values here. And that's what? That was my vertical asymptote, which is at 1/2. So the domain is -infinity to 1/2 union 1/2 to infinity. And this domain is always going to have the vertical asymptote as the breakpoint in our union. And the range is always going to have the horizontal asymptote as the breakpoint, because it's going what? From -infinity up to -1/3. It has to hop that asymptote, then it continues again to +infinity. So it's going to be -infinity to -1/3 union -1/3 up to +infinity. And again, this value in the range is always going to be the horizontal asymptote number. Does that make sense? Any questions on that? We're running down to the last couple minutes here, so let me give you guys the ticket out the door unless anybody has a question. All right. And again, if you need to, you can always go back and just even watch the end of the video if you have to. But so today's ticket out the door, and they're really more review problems. Obviously, there's no door. You're not going to show me your answers here, but you will need these in your notebook for credit. So the first one is find the inverse of f of x is equal to square root of 2x minus 1, and then state the range of the inverse function f inverse of x in interval notation. And then number 2, given r of x is equal to 3x minus 4 over 2x plus 1, find the following. Find the x-intercept, find the y-intercept, find the vertical asymptote, find the horizontal asymptote, tell me the domain, and tell me the range. Give an example. I can't get the correct answer. Okay, so let me give the answers for these ticket out the doors. That way everybody has it. If you want to type in the problem, or if it's easier, if you can type it out, that's fine. If not, if you want to post it on the discussion thread, and then I can go in there and maybe kind of discuss it a little bit. But for now, if you want to try to type it in, I'll see if I can answer it on the board. It might be easier to answer it on the board anyway. So, all right. So for you guys working these, again, I'll give you the answers so at least you have them. Please do work them as you are well familiar now. These are the exam problems. And so make sure you know how to do these kind of problems. So for this one, f inverse of x is x squared plus 1 all over 2. And the range is 1/2 up to infinity. And again, the range of the inverse function is what? This whole thing is really saying what's the domain of the base function, f of x. So the domain of this guy is 1/2 to infinity. So make sure you remember that connection. Then for these guys, x-intercept is 4/3 and 0. 0, -4 for the y-intercept. Vertical asymptote, x equals -1/2. Horizontal, y equals 3/2. And then again, the domain is everything but the vertical asymptote. So -infinity to -1/2, union, -1/2 to infinity. And the range is everything but the horizontal. So -infinity to 3/2, union, 3/2 up to infinity. So again, if you guys are signing off, then bye to you guys. Let me see what I got here. Shada, find the inverse of the function. The answer was this. Let's see. That should be it. It might be a formatting, I would say. If you can, do you want to take a screenshot and, or you know what, if from WebAssign, you can do like email my instructor. If you want to send me that email, I'll see how you're formatting your answer in there, and then I can email you back like what's going on, because it's the right answer. It's definitely 1/2 times x minus 3. So I'm not sure why it's telling you it's wrong though, but otherwise you have it correct. Otherwise, again, we're pretty much, time is up here. If you guys have a question, you can type it in here. I'll hang out for a few more minutes. If not, screenshot if you upload. Okay, perfect, Shada. I'll check them out and then get back to you. Otherwise, you guys have a good weekend. Stay safe. We'll see you next week. And I'll probably put a feed or discussion up on, just kind of get your guys' feedback on this. Is this working for you? If it's not, you know, do you think WebEx would work better? And we'll go from there. Otherwise, you guys have a good night. Have a good weekend. We'll talk to you on Monday. Yes. So there will be an assessment. It will be some of the problems. Well, it'll be from this 2-7 and 3-7. Oh, yes. Yeah. Let me bring the dog. I'll bring you Cash. Cash. Come here, bud. Yeah, hold on, Jenna, if you want to see Cash. Come on, bud. They want to see you. So here's Cash today. Come here, bud. Come here. They want to see you. So here's Cash, my old man, turning 11 this year. So you guys can see Ginger and Bambi next week, maybe. I'll bring those as well. Anyways, back to Marco's question. Yes, we will have an assessment on Sunday. It'll be over 2-7, 3-7, and then some of the questions that gave you guys an issue on exam 2. So, all right, so that's it. Yep, my frosted face boy here. So, right, bud? You want to do videos all the time, or you want to go back to napping? He likes napping, so we probably woke him up from his nap. But anyways, you guys have a good weekend, and we'll see you on Monday.